Hi everyone, welcome back to the continuation of Seaborn tutorials. Today I'm going to be talking about kernel density estimation function. If you remember, we talked about histograms and I told you that histograms are really good for showing the distribution of data. You want to understand what is the structure of your data. The example I gave was the neighborhood. Considering that there are 500 houses in your neighborhood, you are trying to get the data, collect the data for all those 500 houses and say, what is the age range of people in your neighborhoods? Imagine there are 500 houses with one person living in every house. You're going to say from 0 to 5 years old, there are 10 people, 5 to 10 years old, there are 15 people, and so forth. What I have here on this screen is a very good visualization for us to understand what is data distribution and what does KDE or kernel density estimation really show us. Consider these white dots on this screen as those people that we are studying in the neighborhood, and the x-axis being the age, so 0 being on the far left, all the way to 100 years old on the far right, and the number of circles being the number of people who actually are of that age. Say, if this is the range for 70 years old, there are this many people who are 70 years old. Looking really briefly on this data, this neighborhood has a lot of old people because a lot of people are here on the far right side of the distribution. So this is why the data distribution is really important for us in making decisions. If the Department of Health was making a decision whether to make more schools in this neighborhood or more healthcare facilities, they would probably think more about the healthcare facilities because there are far more older people as opposed to younger people. So kernel density estimation is a really useful statistical tool with an intimidating name, often shortened to KDE. It's a technique that lets you create a smooth curve giving a set of data. So what I have here in blue, the blue line is the kernel density estimation that is fitted to this distribution of data. Imagine these circles in white being your histogram in bars that we talked about in my previous video. The blue line is the smooth weighted line that is fit to that data. The KDE takes a bandwidth parameter, which determines how smooth this line will be. So if you sample very in detail, you will have a less smooth line. I guess this blue should come up because we have far more dots around here. If I move my cursor here, you can see that any data points that fall between the red line, those are the ones that are contributing to that blue line in that specific section. So here, for example, in this peak, these circles contribute to this figure, to the blue line going up as it does. As I said, bigger bandwidth should give you a smoother line. So what I'm going to do, I'm just going to reduce the bandwidth and you will see that the line gets really bumpy and goes up and down a lot. But if I increase the bandwidth, I will have a way smoother line. As a data scientist, you should be making the call, what is the best bandwidth for your own use case. But here, I guess I am pretty happy with 0.07-ish because it is not too detailed, but at the same time, it shows more of the structure of the data. I will leave the link for this website by Matthew Conlin, which is going to really help you understand the context of KDE or kernel density estimation. Before we go on, if you enjoyed this video, please like it and subscribe to my channel. It will help this channel grow a lot. Let's go ahead and make a new Jupyter notebook, give it a proper name. I always encourage you to do that because that will make your life easier down the road. So this one is for Seaborn number 4 for kernel density estimation. Import Seaborn as SNS, and from matplotlib import pyplot as plt. Let me remind you of a graph that I have been showing in previous videos because that really matters. If you have been following my Seaborn series, you will remember this graph. If not, I'll take you through again. Seaborn has a flat structure. There are 3 main functions that are used for different purposes. For example, the relplot function is used for relational graphs. The displot is for distribution, which is the focus of today's tutorial. And the catplot is for categorical plots. So my previous video, I talked about histplot, and today I'm going to be talking about KDE plot and displot. But what I would like you to remember is that you don't really necessarily need to remember these subclasses of graphs. If you remember these 3, you can easily access either one of those sub-functions. We know that Seaborn has some built-in datasets that we can use. Let's go ahead and use and load the penguins dataset. So penguins, let's save it in a variable called penguins. And let's have a look at the first 5 rows of this data. We have different species, where they live, what is their build length, what is the build depth, what is the flipper length, and what is the body mass. So before, what we did, we looked at the histogram of their body mass. Let's do that again. I'm going to say sns.displot because I know that based on this graph, if I want to look at distributions, I have to look at the displot. The displot, so what is the name of data? It is called penguins. What is the X variable? I want to look at body mass underscore G. If I run this, I will get a hist plot. So the default of displot is hist plot. But if I want to get a kernel density estimation plot or a KDE plot, all I need to do, I need to say the kind is KDE. What it will do, it takes a bit of time, but what it will do, instead of giving me a distribution based on a histogram, it will give me the kernel density estimation as I showed you in the intro. So there are various things that I can change about this plot. I can change, as an example, the line width to be 4. That will give me a thicker line. I can change the color to be red, and I can set the fill to true, which will fill in with some transparency. So these are the basic things that I can change about my graph. So let me move the aesthetics to the next line because I don't really care about them. If you have been following my Seaborn series, the good thing about Seaborn is that you can use different parameters to feed more data into one graph. So for example, I am only looking at the distribution of body mass for every kind of species living in every kind of island in different sex, for male and females. The good news is that Seaborn has made our lives much easier. If I wanted to understand what is the body mass distribution for males and what is it for females, all you need to do, you can just add a hue variable, which is essentially the color, and set the sex variables as the hue. What it will do, it will give you 2 different histograms, or KDE, depending on what you're looking at, based on the sex, which is male and female. What I can see is that the male population is heavier than the female population because in animals, males are bigger. Were I to look at them in separate graphs, I don't want them plotted on top of each other. I can say, give me the sex in columns. So put the sex variable in 2 different columns. What it does, it separates them and puts them in 2 different columns. You can put them in different rows. So you just say row is the sex, but I don't think it's a really good idea for this use case. So I'm going to set it back to col. Sex, male and female, is not the only class that I care, because when I look at this graph, I can see that the male population has 2 smaller groups within it. It's not just all the males are distributed like this. However, I can see there is one population within the male community that is on a smaller body mass, and there is another population that is heavier compared to the other one. Maybe that's the species. Maybe if I set the hue to species, so I want to say separate the sex in 2 different columns, so I will get this graph and this graph, but instead for different colors, I will get the type of penguins. If I run that, I can see there are 3 types of penguins, so Adelie, Chinstrap, and Gentoo. The males are plotted on the left, the females are plotted on the right, and I can see that Gentoo species is the heaviest species of all the 3. Whereas Adelie and Chinstrap are pretty much the same, they have the same body mass. So could I make this even into more graphs? So can I say, I want 3 columns only for species? Yeah. What I need to do, I need to say, okay, I don't want the hue of species, and I want you to set the column to species. So now I have one KDE for Adelie, 1 KDE for Chinstrap, 1 for Gentoo, without telling me what is going on with the male community and what is going on with the female community. So I like the previous look even better. Back to this graph, I told you that you just need to remember the displot and KDE plot can come with it. But you might ask, okay, I want to understand how to do it with the KDE plot anyways. That's pretty easy. I'm just going to plot the same thing. SNS. This time I'm going to use the KDE plot and not the displot. Data is the penguins data. The X variable is the body mass. And the hue is set to be species. So if I run this, I will get the same graph, but it's not separated for a female or male. You might say, well, this is not separated for different sex, for male and female. Yes, and that's the problem if you want to use the KDE plot. If you use the KDE plot, you can't say, let me do that so that you can see column equals sex. You will get an error because col is not a parameter that is known for KDE plot. So that's why I highly recommend using the Displot. Okay, let's correct that. That's it for the KDE plots tutorial. If you enjoyed this video, please like it and subscribe to my channel. It will really help my channel grow. Thank you.